In this video, we'll start writing our first GraphQL server. We'll expose an API over HTTP, which is by far the most common way to use GraphQL. And we'll do that using Apollo Server, that is a project that makes it easy to set up a GraphQL server in JavaScript with node.js. Let's get started. We'll create a new project entirely from scratch. So in a terminal, I'm going into my projects GraphQL folder, which is where I keep my projects, but you can use any folder you like on your machine, of course. Here I'll create a new folder called Hello World, and inside Hello World I'll create a subfolder called Server. Later on we'll add a client module as well under the same parent folder. Now I'll open Hello World Server in Visual Studio Code. So this is just an empty folder at the moment. Let's turn it into a JavaScript project by creating a package.json file. I'll just set the name to Hello World Server. And that's all we need for now, really. We're ready to install some dependencies. Let me open a new terminal. I'll use the one integrated with the editor so I don't have to switch between windows. Now we want to run npm install, and we need Apollo Server and also GraphQL. The GraphQL package contains the core GraphQL functionality, while Apollo Server is for serving over HTTP. Okay, now that we have our dependencies, let's go and create a new file where we'll write some code. Let's call it server.js. The first thing we need to do here is define our GraphQL schema that will describe what our API can do. We'll keep it in a variable called typedefs, short for type definitions. I'll use a backtick delimiter string so it can span multiple lines. And here we'll use a special language called the GraphQL Schema Definition Language. Let's see what it looks like. We start by defining a type called query. So you can see that to define a type, we write type and then its name, in this case query, and then curly brackets. It's a bit like defining a class in JavaScript, except we write type instead of class. Now, inside the curly brackets, we declare which fields belong to this type. For example, let's add a field called greeting that is of type string. So the syntax for a field is name of the field followed by a colon and the value type. In this case, we used string, that's one of the predefined types. So this is pretty much the simplest GraphQL schema you can possibly have. We only have one query that returns a string. In a schema, we always need at least this query type that contains all the possible queries that can be made by our clients when calling this server. In this first example, we can only ask the server to give us a greeting. Now, we can parse this schema using a function called GQL that we can import from the Apollo Server module. GQL is a tag function, which means we can use it to tag a template literal. In other words, we put GQL before a backtick delimiter string. This is nice because it makes it obvious that this is not just any regular string, but it's a string that contains GraphQL code. In fact, you may have noticed that the editor also applied some nice syntax highlighting because I have a Visual Studio Code extension that supports GraphQL and recognizes the GQL tag. Not only that, but the GQL function parses the string as a GraphQL schema. So our typedefs variable now contains something called a document node, not a string. I'm going to log this object to the console so we can get an idea of what it looks like. Let me open the terminal again and run server.js with node. You can see that typedefs is a JavaScript object with a bunch of properties like definitions, that is an array of other objects. This object represents an abstract syntax tree of the GraphQL code we wrote. But we don't really need to worry about all the details here. I just wanted to show you that the string has been parsed into some sort of object that represents the GraphQL schema. Also, if we make a mistake when writing our schema, For example, if instead of type we write class, which is not the right word in GraphQL, and then we try running our script again, the GQL function throws an error when parsing, saying unexpected name class. Okay, now let me revert class back to type and remove the logging. And that's it. We have our first GraphQL schema definition ready. In the next video, we'll see how to actually implement the functionality defined in the schema. In the previous video, we wrote a schema definition for our first GraphQL API. According to these type definitions, clients can call the server and ask for a greeting. That's the interface of our API, if you like. Now it's time to provide an implementation, that is, specify exactly how the server returns a greeting value. We'll do that by creating an object called resolvers, which is just an object literal. This resolvers object needs to match the structure of our type definitions. So first of all, it needs a property called query. And query will be a nested object because it represents a type. And it has a property called greeting, just like the field we declared in the type defs. This, however, will be a function that will return the value of our greeting. Let's return a message saying, "Hello, GraphQL world." So this function will be called by the GraphQL engine every time a client sends a greeting query. Or, in other words, this function will be called to resolve the value of the greeting field. That's why in GraphQL jargon, this is called a resolver function. And this also explains why we named this whole object resolvers. Now, let me stress that the resolvers object needs to mirror the type definitions precisely. This is important, otherwise things won't work correctly. So resolvers has a query property, and note the capital Q, that corresponds to the query type in the schema. And the query object has a greeting property that matches the greeting field in the type defs. The only difference is that the schema simply declares that greeting is a string, while in resolvers we provide a function that returns the actual value of the greeting. In this first example, we're just returning a hard-coded string here, but since this is a function, you can imagine that we can have any logic we want. For example, we could load the greeting value from a database, or we could generate a random message dynamically. So at this point, we have our type defs that are the interface of our API and the resolvers that are the implementation. We're ready to put everything together and create our server. To do that, though, we need to import the Apollo server class provided by the Apollo server module, because our server variable will be a new instance of Apollo server. The Apollo server constructor takes an object where we can pass configuration properties. In our case, we want to pass our type defs and our resolvers. Note that we can use the shorthand syntax here because the property names expected by this object match the name of the variables we defined above. Finally, we want to start the server by calling its listen method. And listen also takes an optional configuration object where I'm going to explicitly set the port to 9000. Now let's look at the signature of this listen method. You can see that it returns a promise of a server info. Since it returns a promise, we can call then, passing a function that takes server info as argument, and log a message to the console. Let's say server running at, and here we can use that server info object. You can see that it has a URL property, so let's print that out. In fact, since we're only using the URL property, we can destructure this server info object and only extract the URL, just to simplify the code a little bit. Okay, that's it. We are ready to start our server by running node.server.js. There you go, we have our first GraphQL server running. As you can see, there's not a lot of code required to set up a GraphQL API thanks to Apollo server. In the next video, we'll see how to connect to our server and make a GraphQL query. Okay, now that we have our first GraphQL server running, we can see how to make queries. If we go and open the server URL, it will show a tool called GraphQL Playground. This is a very convenient user interface that allows us to test our API directly from the browser, and it's enabled by default with Apollo server. The first thing I want to show you is this docs panel. This shows some documentation generated from our GraphQL schema. You can see that this API exposes a single query called greeting, just like we defined in our server code. And if we click on a query, it will show more details about that particular field. In this case, it explains that it returns a string that is a scalar type that represents textual data represented as UTF-8. So that's quite nice. We get some auto-generated documentation for free. But the main feature of this tool is being able to make queries, and we do that in this left panel here. Now, GraphQL queries are written in a special language, the query language, that is in fact the QL in GraphQL. If you press Ctrl space, the playground gives you suggestions, and you can see that we can start with either query, mutation, subscription, fragment, or, strangely, with an open curly bracket. We'll see what each one of these means throughout the course, but for now we just need a regular query. Then we write curly brackets, and inside we can specify which fields we want. Again, Ctrl space will give us the options, and the first one is greeting, so it's clearly using our schema to know which queries are available. Let's select greeting, and that's it. This is now a valid query. We can run it by clicking this button, and you can see the server response on the right. It's a JSON object that contains a greeting property with value hello GraphQL world, which is of course exactly what we wrote in our server code. If you notice, the greeting is enclosed in another object called data. What's the point of this data object? Why not just return the greeting value without wrapping it in another object? The reason is that you can have another top-level property in the JSON response that is not data. For example, let's see what happens if we make an invalid query. Say we mistype this field name and ask for greetings. Now, instead of data, we get back some errors. And incidentally, we also get a pretty detailed message saying cannot query field greetings on type query, and it even suggests did you mean greeting? It's always good when a framework provides nice error messages. It makes debugging a lot easier. Anyway, let's fix our mistake and go back to greeting. Another thing I want to mention is that writing query here is optional. We can actually delete this keyword and it's the same thing, because query is the default operation. If we run it, we get the same result as the first time. So starting with the curly bracket is the same as writing query. Now, before wrapping up, I want to make sure you understand the relationship between a GraphQL query and the schema that's defined in the server code. Let me put Visual Studio Code on the left half of the screen and Chrome on the right-hand side, so we can see both the editor with the server code and the query in the browser side by side. Now, notice how at the top level of the client request we have query. This matches the query type in the schema. You could actually argue that it's not exactly the same, because in the schema we have query with a capital Q, while in the request it's all lowercase. There's actually an extra step involved that's not currently visible. Let me update the schema to make it more explicit. At the top level of the schema, we actually have an element called schema that is the entry point, or the root element if you like. And it's this schema element that contains the query operation. And here we declare that the query operation with lowercase q is described by the type called query with uppercase q. We initially omitted this schema element because this configuration is the default. Unless otherwise specified, the query operation will map to a type called query automatically. But this way it should be clearer that the query element in our request matches the query operation in the schema, which in turn maps to the query type. Anyway, once we've found the right type for the requested operation, we also know what fields we can request. Here we can request a greeting because that's a field declared in the query type. And when the server receives this request, it will map it to the resolver function for the greeting field, resulting in this value being returned as part of the server response. Now, this is a very simple schema, so the mapping between query and schema is also pretty simple. But you can have far more complex schemas, as we'll see in the rest of the course, and understanding this relationship between schema and queries is important. In the previous video, we wrote our first GraphQL query. We used the GraphQL Playground, that is this visual tool that comes for free with Apollo Server. And the Playground is effectively a GraphQL client. It's an application that runs in the browser and sends requests to our GraphQL server. In the next video, we'll write our own first GraphQL client. But first, let's have a look at how the Playground works, and more specifically at the HTTP requests it sends to the server. I'll open the Chrome Developer Tools and then the Network tab. Let's clear all the previous requests. And now, if we execute our query again, you can see that it sent a new HTTP request. Let's examine it. For a start, the URL is localhost and port 9000, which is of course where our GraphQL server is running. More interestingly, the method is post. So this is a difference compared to REST APIs. With GraphQL, we always make a post request, even though in this case you may think we just want to get the greeting message. Now, if we look at the request headers, the content type is set to application JSON, so the client is posting some JSON to the server. And if we look at the request payload, you can see that it is in fact a JSON object with 3 properties. Let's ignore operation name and variables for now that are just empty anyway. The important one is query. You can see that the value of this string is pretty much the same as what we entered in the left panel, except that the new lines have been escaped in the JSON string. So that's the request. Now let's look at the response from the server. We got a 200 OK status, meaning the request was successful. Then, if we look at the response headers, the content type is application JSON. So just like the request, the response is also in JSON format. And finally, if we look at the response body, you can see that it is a JSON object. And in fact, it's exactly the same object we see in the right panel of the Playground, apart from the indentation. So that's what a GraphQL request looks like when sent over HTTP. The client is posting some JSON and the server sends some JSON back. Nothing too fancy. Now that we know this, we're ready to write our own GraphQL client, and we'll do that in the next video. So that's what a GraphQL request looks like when sent over HTTP. The client is posting some JSON and the server sends some JSON back, nothing too fancy. Now that we know this, writing our own client should be pretty simple. Let's go and create a new project. I am where I created my Hello World folder that contains our server project. I'll now add a client folder as well and open it in Visual Studio Code. So as our first GraphQL client, we'll write a basic web page with some vanilla JavaScript code that sends a request to our GraphQL server without even using any frameworks. Let's start by creating a new file called index.html, and here I'll use the HTML5 snippet to generate the basic HTML boilerplate. So this is just an empty web page. Let's set the title to GraphQL Client. Then let's add an h1 heading, also saying GraphQL Client for now. Now let me open this file in the browser. And this is our basic page. Nothing exciting so far. I'll keep the browser and the editor side by side so we can see both. Now let's say that instead of this text, we want to display the greeting message returned from our GraphQL server. Let's change this text to loading initially. Then we'll replace the text once we get the response from the server. Next, we'll add some JavaScript code. So let's add a script tag and set the source to app.js. Then let's go and create that app.js file. And here we'll write the code to fetch the greeting from the server. So let's write a function called fetchGreeting. There are a couple of ways to make HTTP requests from the browser. In this example, I'll use the fetch API, which is a web standard, so we don't need any additional libraries. The URL we want to call is the same one we used in the playground. Let's create a variable at the top called GraphQL URL and paste the URL here, localhost on port 9000. So we want to fetch that URL, then we need to pass some options. The method must be post. Next, we want to set some headers. In fact, we just need one, that is the content type. And this will be application/JSON. Finally, we need to send a body, and here we can use JSON stringify to convert a JavaScript object to JSON automatically. In the body, we need a query property, and the value of this string will be exactly the same query string we used in the playground, so let's copy it from there. And then paste our query string into our code here. That's it for the request. Now let's process the response. I'm going to declare this function as async, so we can use the await keyword inside this function. Now let's get the response by awaiting the result of fetch, since making an HTTP request is asynchronous. Next, we want to parse the response as JSON, and this response object has a JSON method to do exactly that. So the result will be the response body, and we need to await the result because with the fetch API, parsing the JSON also returns a promise. At this point, let's just log the response body to the console. And for now, let's just call our fetchGreeting function right here, so it will run as soon as the page is loaded. Let's save this file and see what happens. I'll open the DevTools so we can see the console messages. Now let's reload the page, and that's the server response in the console. As usual, we get our greeting message wrapped in a data property. Since we know the format of the response object, we can extract the data property from the response body using the object destructuring syntax. And instead of logging the response, let's return the data. The final thing we want to do is replace the text in our page with the greeting returned by the server. So here we can call then, because fetchGreeting is an async function and therefore returns a promise. And here we'll receive the data that we can also destructure, extracting the greeting property, which is all we need. Once we get the greeting, we want to change the text displayed on the page. Let's have a look at our HTML again. We want to set the content of the h1 tag. So in our JavaScript code, we can use document query selector to find the h1 tag by name. We know there's only one h1 tag in our page. Let's assign the element to a variable, say title. Finally, we can set the title text content to be the value of the greeting we got from the server. Right, let's see if this works. If we reload the page, there's our Hello GraphQL World message. So this is a simple example of how to make a GraphQL request over HTTP. There are also GraphQL client libraries available for many languages that make things a bit nicer, but I wanted you to understand that at the end of the day, any GraphQL client just uses HTTP under the hood. There's nothing magic going on. And since it is just HTTP, this also means that we can call our GraphQL server from pretty much any language or platform as long as it provides a way to make HTTP requests.